Welcome to Calculus in the PM. I'm your host, Mr. Snellkens. Now, we took a look at this. We also played around with calculators. I showed you some shortcuts. They're not so short on this to take advantage of this particular example, but how to store things in there. Generally, if it's not an ABC kind of a long answer question, you're usually quicker to just enter the function the way it is, right? Just directly on there. If you want to store it as equation y1 or whatever, or y2, if you're going to do multiple calculations with it, then that's the way to go. But you know both ways. Okay? Was there any questions about the questions you may have looked at last week? I asked you guys to hopefully get a good chunk of them done over there, because I know you guys were behind a bit, okay? Now, before we go too much further, another message from our sponsor. The wrong one. I'd like you guys, when you get home, have a nice warm cup of soup from our sponsor, Campbell Soup. Washroom. It's a typo. It's mushroom soup. Well, all of their soups. Tomato, cream of celery, herb basil. They're all delicious. Just pour yourself a cup of, it's like giving yourself a hug. Have a warm cup of soup. Okay, now, continuing on, sponsorships. Boundaries with changing functions. Changing functions, what's he talking about? Well, let's see what we're talking about. Page 3, y'all? If a boundary of a region is defined by more than one function, we can partition the region into subregions that correspond to the function changes and proceed as usual. Now, let's take a gander at this. Example 4, using subregions. So you can cut it up, and we know this. You can cut up integrals into 2 or 3 parts, as many as you need. Find the area of the region R in the first quadrant, bounded by y equals the root of x, and below it, by the x-axis. And the third thing is the line y equals x minus 2. Now let's think about this. I think you know a bit about the first function. Actually, we were just looking at root functions, weren't we? So that's a sideways, half sideways parabola. And at 4, you get a y value of 2. At 1, you get a y value of 1. Okay, so if I do that one, I'm doing blue. 1 would be 1, sort of about, I'm just approximating it, about here. 4, square root of 4 is 2. I'm just approximating here. That's not bad freehand, like for a guy like me. Then, by the x-axis, so that's the line y equals 0, right? Y equals 0. Y equals root x. Y equals 0. Keep that in mind sometimes. That's, the x-axis, right? It's not too complicated. And then the line, x minus 2. We'll do that one in red. X minus 2 is a 0 at 2. This makes it simple. And where will it be at 4? 2. So hey, intersection in my direction. And let's see here. I gotta just get the view master back here. Sidebar. Okay. I want the starting, and I want to choose red. All right. So there's my chunks, right? My 3 functions. Okay. Typically on an AP question, typically, not they're always different, they'd have something graphed with you, but it'll be a lot trickier than these two. Some aren't. People always focus on the craziest ones or whatever, and I will too, but they're not all gloom and doom. Now, do you see if we're doing area here? I'm going to maybe grab this off again here, this little beggar. And I'm going to change it to just a dotted line only because I want to use it like a stick here. Okay. Nope, don't want to do that one. There we go. Now, I want to find the area. I can see that 0 to something, the blue function is on top, right? The bottom function is y equals 0, the x-axis, right? Then do you see it all changes there? So this area here we'll do as one chunk. Because we want to find the area then that's bound to the other half. Well, here, I'll color it in one way. Okay, this is the one area, and then I'm going to do a second integral because the bottom function changes, doesn't it? And I'll do horizontal lines. You guys see the difference, right? Okay, now that's so the area is. Let's get this going on here. The area, in this particular case, where would I go from 0 to 2? Well, I mean, function-wise. We know it's from 0 to 2. What's my top function? Minus my bottom function.
Root x.
Root of x minus 0. So I'm going to just go with root x. And because it's easier to do calculus operations typically with half as the power, right? So I'm going to write it as x to the 1/2. I won't write the minus 0 down there. We know we've done that. Top minus bottom. Dx. As a matter of fact, you know how you were always doing areas to the x-axis beforehand, before this section? You were just assuming any area you did in an integral will give you that. The reason why you just wrote down the function is because the second lower function was the x-axis, y equals 0, and you were subtracting 0. Does that make sense? The bottom function was always 0. Anyways. Now, this chunk. We've got to now subtract the other functions. So I'm going to go with, well, I'm going to just change colors just so you know where things are coming from. And I like colors. Colorblind. Subtract, or not subtract, add 2 until 4. My top function would be still x to the 1/2. But I'm subtracting x minus 2. Now, I'm going to go ahead, do it all in one step, drag that negative sign through, but that's where people forget this. So that's why I really wanted to emphasize minus bracket x minus 2. Okay? So, the actual calculus part of this, once you got this down, isn't too bad. It's new. It's improved, it's old-fashioned. It's all. Turns a sandwich into a banquet. And $1. So we got some calculations to do, right? I hear 2/3. Do I hear 2/3? Okay, I'm going to drop the colors. Then, now, before I'm doing this here, I'm actually going to just think this through here. This part right here is x to the 1/2 minus x plus 2, right? That's what I'm thinking. I would have even, actually I would have jumped into that probably, right? anyways, that's what I'm doing the antiderivative of here. I'll just move this down so that where was I? X to the 1 half? Well, that's the same antiderivative. Minus x, half x squared. 2x. Right? 2 and 4. Now what? It's just arithmetic from here on. Okay? Now, I don't think it's a big deal to do this arithmetic, but just take a look here. What is the first expression? Because it's going to be minus 0 in the first part. But what's the 2 part? You can't do the square root of 2. Easy. It's just, so what is it? 8. Square root of 8. 2/3 root 8. Now you could break that down a little more, but we'll just hang on to it as that. Okay? Just wait though. Sometimes 2 root 8 over 3. Agreed? Now there's going to be something going on here, so. So you can work it out because it's square root of 4 times 2, right? You switch it there. That's cool. That is correct. But I won't do too many things at one step. Sometimes you don't have to do them. Now when I plug 4 into this expression, though, so I'm putting 4 into here, here, and here, right? First, and then subtract. So when I put 4 into there, the square root of 4 is 2. So I've gotten rid of the root. I'm doing the very first part of it. So where am I? Square root of 4 is 2. Cubed, 8, 16/3. Stop me when I make mistakes. Because you guys should be doing this and checking. Saying, why aren't you the same as me? 16 over 2 is 8. Put number 2. Hey, see why you're saying we don't have to worry about simplifying that radical, that little rascal? Because it's gone. The 2 root 8 and the minus 2 root 8 over 3, both of them. That's gone. Minus 8 and plus 8 are gone. All we're left with is negative 2 plus 4 and 16/3. So let's just do 16/3 plus 2. And then plus 2, I'm thinking of 6 out of 3, right?
Wouldn't it be minus?
Subtract. Thank you. Let me see here. Yep. Here's why. Subtract opposite sides. Thank you, young man. Trying to do too much at once. Recipe for disaster. Negative 2 plus 4 is positive 2, but it's being subtracted. So 6, anyways, out of 3. 10, now apparently, yeah, 10/3. Sorry, it's positive. 10/3. Okay, got it. Be able to do the arithmetic without a calculator, be able to do it with a calculator, but that's usually I don't have to demonstrate that. Okay? But things with fractions you should be able to do. And as you can see, I'm glad you only caught one error, like I didn't make that many errors yet. I do make errors. Now sometimes, think of the graph sideways. If you had something that it's easier to think of by twisting the page sideways and thinking of the y-axis as your horizontal, like if you literally twist it. So I'm looking at this like this, right? You see there x equals f of y. X is equal to some function like y squared plus 5 or all that kind of stuff. It's the same stuff though when you have a dy it doesn't mean, like, the operation's the exact same. And guess what? Think of the top function as the higher valued function, right? These y values, I mean these, when we're talking about as a function of y, the x-axis is higher here and lower over here, right? So this would be like my top function here. This would be like my bottom function there, right? If you're looking at it sideways, if you're integrating with respect to the variable y, you're viewing it as if you're sideways, yes. Not entirely a big change, but as long as you view it that kind of way. So whatever's top will give you the higher values. Okay, so here's the higher values. Okay. Now, pardon me, find the area of the region bounded by the curves x equals y squared minus 1 and x plus 1. Well, y squared minus 1 is just a parabola on its side. It's not a function, it's an expression or a relationship. We'll do that. Actually, we just had that one up here with the example I had earlier, right? Okay, there's my x equals y squared. Excellent. I'm not used to this. I'm always writing y equals. And then y equals x plus 1. This is written in the other way. Now that's not that tricky, but y equals x plus 1. So if I plug in 0 for x, y equals 1. Let's follow this. That's the same as here. Well, I'm going to choose a blue pen, I guess, for this one. And then, okay, little buddy. The function is kind of off here. Or I'll just draw it. I'll just redraw it. There we are. This is the area that we want. And where it's trapped there, which is the top function according to, like, dy, right? Is it the blue line, or is it the red parabola sideways? Top function, but we're doing it with respect to y. So it's the blue one, because we have an x equals y squared minus 1. If you wanted to do it, and you can do it the other way around, you have to solve for the square root of, if you want to do it with dx, the red is the top. You'd have to solve, and you'd only get half of this, which is fine for this problem, and you'd involve a square root over the expression, right? It's a little more complicated. This is actually easier, if you could see this way. Anyways, so I think of my blue as my top function. So the area in this case. Now, I am now going, though, from here to here. You follow me? From y equals 0, which is my bottom point, to y equals 1. Going in between here, right? This is sideways thinking. 0 to 1. The first function I'm going to use is my one with greater values, x plus 1. Subtracting. Yep.
Why wouldn't it be from 1 to 0? Does it not matter if you go left to right or right to left when you're saying up here?
Least degrees. And then you get positive areas. Honestly, too, if you make a mistake and you start doing this, and you know that the area comes out, because we're doing area, if it comes out to be -5, all you have to do then is just step back here and reverse these, you know what I mean? Like, that makes the sign opposite, doesn't it? You can repair your work kind of thing after the fact. So, dy. Now, this part of it, the arithmetic and everything else that follows is the exact same. It's just this setup, okay? So let's just see here. Can you group any? Hey, what did I do that was stupid? I have mixed up. My blue is garbage, isn't it? I was just blindly doing this. This is solved for y, this is solved for x. The whole point I was saying, if you wanted to solve this for y, it's going to involve a square root and a tougher integral. We can do it, not yet. Oh no, we have taken substitution, but it'll involve more stuff. Dalka. Surprised you guys didn't catch that. I'm not surprised that I made the mistake. I'm surprised you guys, I thought you were better than me. Solve this for x. My mistake. Y minus 1, right? You dig that, brothers and sisters? Digger, from site 77 or 78, the Warriors.
So good. The soundtrack.
I'm all to play. When I was 7 years old, that's the way I...
And then people radios actually like start riots in the streets in January.
Crazy. Now, math wars. We could take a look at this. There's not much to group like term-wise, but it's y squared. Did I do it the right way? I'm just taking a look here. Yep. Plus y. Minus y squared plus y, I guess you could say, or y minus y squared. I don't care which order you do it. I'm going to rewrite this one because I've made enough mistakes already. Which way do you want to do it? Okay, negative y squared. Because the ones cancel. Okay. Third, right? Negative 1/3 y cubed plus half y squared. 0 to 1, this makes it a cinch because the zeros are zeros and ones aren't bad either. So negative 1/3 plus 1/2 minus 0 popped in there, so nothing. There's a lot of expressions that you do that go from like 1 to 0, 2 to 0, 3 to 0, and so on. So much so that people get in the habit that they forget they're actually subtracting the second part. And then when they get one that goes from 1 to 3, they just do the first part and they forget to do the second part. Keep that in mind to say, okay, and then minus whatever 0 gives. Nothing here. So this is just arithmetic. What is that, out of 6 then? Negative 2, 6 plus 3, so 1 out of 6. And if you did it the other way around, if you solved the half a quadratic equation, square root, you'd still get the same answer. And your calculator cannot do solving for y stuff. You have to either pretend all your y's are x's and reverse them on there and do your arithmetic if you want to use a calculator. That's one way. Or solve them for x. That's another way. Now, that first problem we had today, we could redo it. I'll just show it to you and then turn you loose on some stuff. 250? Okay, good. This one here. This is the same stuff that we had initially, right? So I'm going to just grab this. Now I'll just do a quicker sketch. Or is that, is that a different one? Oh, that is a different one. Okay, it's slightly. Yeah, similar kind. Okay. Now I'm looking at it. X minus 1, so it's low, up 1. This thing sticks it all together. Okay, this is like the problem, right, where we broke it up into two chunks. But we could also do this using geometry. Okay. What's the y-coordinate at 3?
When it's root x plus 1, doesn't it start at 1, or does it still
Okay.
work at 4?
This?
Yeah.
Okay, let's put it in 0 and you're right. It's up high.
Yeah.
Sorry, yep. I'm gonna redraw this. I had it in my mind when I had this that this is the same problem as the other one. You're right. It's the same problem but slid over.
Yeah.
Thank you. Yeah, it does start. I wasn't even looking at that function, and actually I was just coming to that conclusion as I was trying to plug this in. Thank you. Okay. Now before, we broke this up into a similar problem. We broke this up into two chunks, didn't we? What if, and this is the using geometry idea, what if I did the integral from -1, which I'll write down. So from -1 up to 3. If I did that, I'd also have this area included, wouldn't I? What's this shape here?
Triangle.
Triangle. And you know how to subtract, or you know the area of a triangle, right?
Yes.
So if you do the area by finding the integral from -1 to 3 for root x plus 1, right? And you could do an integral, but why would you? It's an area. 1/2 base times height. What's the base of that? 2. 3 minus 1 is 2. And a height of? 2. 3 plus 1 is 4, square root is 2. Yeah. 1/2, 2 times 2. So minus the area of a triangle, right? That's the area of the triangle that's right here. Why would you? You could do calculus if you wish. You could use the x minus 1 graph. Yeah.
Do you mean root x plus 1?
Oh, I forgot to put the half there. Thank you, ma'am. Getting too excited with the other stuff. Is that 3 errors today? Not good. Okay. Okay, the integral part. You're getting me just going on this. Let u equal x plus 1. We'll use some substitution here, okay? You can do this without substitution, but hey, why? So if you let eu equal x plus 1, what does du equal?
X squared over 2 plus x.
Not log of that.
No.
Do it again.
If you don't have to use substitution, but what is u? If u is this, what's the derivative of that expression?
1 no longer.
1. du by dx is equal to 1. du is equal to dx. Yeah.
Yeah.
Okay.
Yes.
But then It might be easier to think about this. So when x equals 3, what is the u value of that corresponds to the 3 spot? 4, right? When, that was an x. When x equals -1, that corresponds to a u value. I should have put it this way around, I did it backwards. Corresponds to a u value of 0. Hey, this turns into the same integral we had before. So when I get this back into the expression, area equals, I'm going now from 0 to 4, du, yep, that's a direct match, so u to the 1/2, substitute it, du, subtract, I can do this in my head too, right?
Calculator.
You'd use a calculator, yeah. Okay, now, what I just showed, you don't necessarily have to use substitution. If you're used to this, but I don't know, you guys haven't really had a lot of practice chance. I can't make up more time, but anyways, if you could do that without substitution, go for it. As you do more, you will. Back to this, though. We did this one before, right? And? Wow.
Yeah, it's kind of
2/3, u 3/2. Okay, so yeah. 2/3, u to the 3/2. Going from 0 to 4, subtracting 2 from that answer, and 10, not 10/3, 4.
Yeah, you forgot the first bracket.
Okay, yeah, you don't need, and that's, I'm not trying to be a goof there. If it's one expression, like there's no +5 and stuff in here, you can get away with just having the line, but that's fine to do this. What I'm saying is if it's x plus 3, then you definitely need this bracket. And they often use a round at the start or a square at both. If it's just like x, you really only need it there. But I tend to always put it at the front. That's good though, yeah. Back to B. Okay, so where was I? 8, 16/3, right. Minus 2, which is 10/3. Same as the other time. Which way is easier? Cutting it up into 2 chunks or recognizing the triangle? Keep it in mind.
This function was easier to do, just because it just matches.
So, like what I'm saying is that this problem right here, you could have just done it as the square root of x, integral 0 to 4, and then taken out the area of the triangle underneath, if you recognize it. Or you could chop them up. There's 2 ways. And it depends. You know how these AP problems sometimes are. One, they'll give you this same problem, telling you that the area of some trapezoid is such and such, and you just kind of use, you could use reasoning like this, where you have to break it into 2. It might involve reasoning like this, where you have an actual shape you recognize. Try some of these problems again, okay? Like, work further into them. How far did you get into them, Tristan? At all?
No, I was studying for the test.
Okay, good for you. Mr. Morris, did you get into these problems? No? You're an honest person. Anybody get into these problems last?
Yeah, we can study.
I'm trying to study for the test.
Have you really?
My plan is to do this
Okay.
Monday, Thursday, Friday.
That was full of lies.
On so many levels.
Monday, Thursday, Friday.
I'm just never.
What?